Polymerization. This part is very important in our curriculum. We have two types of condensation polymerization. We have a polymer named nylon, a polyamide. Also, we have a PET, a polyester polymer. These two are formed by a type of polymerization called condensation, as we have two products. One of them is water. The first type we're going to discuss is nylon. Nylon, a polyamide, is formed from a dicarboxylic acid and a diamine. Let's see what is meant by dicarboxylic acid and what is meant by diamine. Actually, the dicarboxylic acid is formed from a carbon atom bonded with OH and a double bond O, and we have a box which contains a radical CH2, CH, whatever the number of carbons, and a bond with C double bond O, OH. We say dicarboxylic acid because this compound has two functional group dicarboxylic acid, C double bond OOH, C double bond OOH. So di means two, one side C double bond OOH, and the bracket which contains number of carbons, and the other part of the box is C double bond OOH. Plus the other molecule that it will form nylon is diamine. Di means two for the functional group NH and NH. On the both sides of the square, we have also here CH2, CH2, whatever the number of carbons as a radicals, and the two boxes at the end of this and is NH2. So they will react with each other to form nylon. How? By removing water. How they will remove water? We will see that the OH of this box, of the first box, will be removed with the H of the other box, of the diamine. And the OH of the carboxylic acid will be removed also with the other H bonded to the nitrogen atom. So we have how many molecules of water? We have two. OH with H, it's one H2O. It will be removed, and from the other carboxylic group OH with the H, it will form a water also. So here we have the nylon. Without the OH, here the bond will be bonded to another unit, and the C double bond O the same, the box will be the same, then the bond. Let's see that we have to focus that the bond here with the connected to the box is the two functional group of the carboxylic acid. Then we're going to bond, the carbon will bond with the nitrogen. So the carbon here will form a bond with the nitrogen to form the polymer. This is the bond. And we're going to draw the second molecule the same. The box bonded at one bond nitrogen and the H as it is. And then the other bond to the box is the N, the same, and the H. And we have the bond because always the nitrogen is surrounded by three bonds. Here we have the nylon, which is a polyamide. Then we have a natural polyamide. It's also a condensation polymerization. It is from amino acids. Amino acid will react with other amino acid to form a protein. We call this natural polyamide. The natural polyamide is formed of nitrogen bonded to radicals, CH2, CH, whatever the numbers, the same, from one direction of the box here of the radicals, the nitrogen and NH2. The other bond will be the carboxylic acid group, C double bond OOH. So this compound is called amino acid. It will react with another amino acid. And of course here we have the difference. The CH2 is different here, the radicals are different. So we have to, if we're going to make lines for the first bracket, we're going to shade with spots or dots with the second bracket. And then we're going to remove water. So we're going to remove the hydrogen here with the OH to remove one water, and the hydrogen here will be removed with the OH. Then the carbon will bond with the nitrogen to form a protein. Nitrogen, let's see how we draw it. Here we have the nitrogen, and then we have the bond. Also, that we know that the nitrogen is surrounded by 3 bonds. And then the bracket, here the bracket is bonded with the carboxylic acid, C double bond O. Then we have the linkage, C bond N H. And then we have the bracket which is dotted, and then the other bond with the bracket is C double bond O. Then we have a side product which is the water. Another type that we have condensation, polymerization is nylon. Nylon is a polyamide. And also, as we finished it, we have the PET, a polyester. The polyester PET is a dicarboxylic acid and a diol. Dicarboxylic acid means the molecule has 2 carboxylic acid at the bonded, which is in the bracket also a radical, a series of numbers, CH2, CH2, whatever the number is. One of the bond of the bracket, C double bond OH, and the other is C double bond OH. So we call this di because it's 2 carboxylic acid, dicarboxylic acid. And diol means dialcohols, 2 functional group of alcohol, so we call all diol, OH bracket OH. So when they react with each other, also molecules of water will be removed. So, and there will be a bond. So we're going to remove OH with one H of the alcohol and OH with the other H. And will be a forming of linkage. The carbon will link with the oxygen to make ester linkage like this. So we're going to remove the OH and the bond will be left on the carbon, double bond O. Then the bracket shaded, and then the other bond with the bracket is C double bond O. Then the bond which will be with the alcohol O, and then the bond with the bracket the same, and then the bond and the bracket and the O, and we have another bond for the oxygen because oxygen is diatomic, it has 2 bonds. We call this molecule a PET, a polyester. Also we have the water as a product. Let's move to the questions. Compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed from a dicarboxylic acid and a diol. So what we have here is a PET, a polyester. This is one of the questions which came in exam 2023. Then we have here another questions. Circle 1 repeat unit of this polymer. So we're going to see what is the repeated unit here. So the repeated unit here is, we have the dialcohol, this one, and the dicarboxylic acid. So this one will be the repeated unit. Then he asked me, draw the structures of the monomer which make up PET, draw the functional groups using the display formula. So we have here, we're going to draw. The first molecule is the diol. So we're going to take it, and then we're going to add the hydrogen at the right and the hydrogen of the left. So this will be the first unit or monomer. Then we're going to remove to the other one which is shaded, and we're going to draw it, C double bond O, and we're going to add the OH, and then the same, the bond and C double bond O bond, and we're going to add the OH. State the type of polymerization used in making PET. It is, of course, condensation, because we have another type which is called addition and only one product there. Let's move to a question. A repeat unit of a condensation polymer is shown. The polymer is made from two monomers. Draw the structure of monomers used to produce the polymer. So here we're going to know. How we're going to know? We're going to see here the bond. So that means that the removing water will be from these two molecules. If we add here OH and we add here OH, we're going to have the first monomer. So we're going to draw the C double bond O, and then we're going to add the OH, and then we're going to write the CH2. I wrote it like this to be obvious that the CH2 is a bond surrounding the carbon. And then the carbon will be bonded to the C double bond O, and then we're going to add H, OH here. Then we're going to draw the second, it's a diol, we're going to add just H here and H there. So the second monomer, we're going to take the O and draw the H, CH2 bond, CH2OH. The two monomers shown can be used to form a condensation polymer. Which small molecule is released during this reaction? Of course, water is the correct answer. What is the structure of PET? So, the PET is formed from, we have dicarboxylic acid, it must be dicarboxylic acid, and it must be diol. So, here it's not, here a diamine and a dicarboxylic acid. So, A is not correct. Here we have, yes, we have a dicarboxylic acid and we have a diol. So, B is a correct answer. Of course, C is wrong. D is wrong because one of the bracket here, it's not O, it's C. So it must be the same O here at the right and O at the left. So D is not correct. Thank you.